So there is the standard 3 review sheet for the master exam. These are the same problems that we had for Power Standard 1, but now we just have to actually put them together. So if we're drawing this out, standard hoop is 10 feet above the floor. Okay, the basketball player is 6 feet. All right, the tricky part for this is that means the triangle height, if you subtract 10 and 6, means from his eyes to the top of the hoop is 4 feet. Okay. Next, they are 15 feet from the base of the hoop, and we want to find the angle. So if we have the opposite and the adjacent, we're using the tangent function. So this is the setup. Okay, if we want to solve this, we're going to do the inverse tangent on a calculator of 4 divided by 15, which will give us 14.9. Okay, make sure your calculator is in degree mode and not radians if you don't get 14.9. So Jack and Jill recently bought a log cabin adjacent to a pond. We're trying to find the length of the pond. So Jack and Jill decided to use trigonometry. Awesome. Jack stands 120 meters from the cabin. So here's Jack and 120 meters away from the cabin. Jill stands 200 meters. The angle formed by Jack, the cabin, and Jill is 95. Now, the tricky part of this is whatever's in the middle of the people that we're talking about, or whatever we're talking about, is going to be where the angle is. So at the cabin, which is between Jack and Jill, is 95 degrees. We want to find out x down here. What is the length of the pond? Okay, so this is going to be a law of sines or cosines problem. Because we're not given a pair, okay, of an angle and its corresponding side, that means this has to be a law of cosines problem. So we're going to have x squared equals 120 squared plus 200 squared minus 2 times 120 times 200 times the cosine of 95. Now, when you're doing these types of problems, please use the formula sheet. It's listed on the Master Exam Review page. Okay, so have that up for doing these if you don't remember the law of cosines, because it's on there. All right, and then I don't need to see all the work, I just need to see the answer. So I'm going to do all this in the calculator. 120 squared plus 200 squared minus 2 times 120 times 200 times the cosine of 95. And that equals a big number, but remember it's squared, x squared. So we're going to take the square root of that answer. And now we'll get x is equal to 242.04. Okay. So this already has the stuff listed for us. There's a couple things that we could do. The 5-foot strap is located here. X, we want to know how far the strap is from the base of the tree. There's a 25-degree angle between the tree and the strap. So right here between the tree and the strap is 25 degrees. Okay. How far is the strap from the base of the tree? Okay, so in this case, we're using law of sines or cosines again. Because we have a pair, we're using law of sines. So we have the sine of 108 over 5 equals the sine of 25 over x. So that's the setup. Now we just have to solve it. So we have 5 times the sine of 25. Divide that number by the sine of 108. And we get 2.22. And that's it. Again, I don't need to see the work. If you're doing it on the calculator, just do it in the calculator. Okay. This question has 2 parts. All right, we have our 2 balloons. The first is 12 miles from the airport. The second is 17. The observed angle between the 2 of them is 70 degrees. How far apart are they? So we want to find this distance. Okay. Again, there's no pairing here, so a law of sines or cosines means you're going to do a law of cosines. Okay, so we have x squared is equal to 12 squared plus 17 squared minus 2 times 12 times 17 times the cosine of the angle, which is 70. Again, you can put this all in your calculator at once, so 12 squared plus 17 squared minus 2 times 12 times 17 times the cosine of 70. We get a big number, but again, we have to square root that number. So x is going to equal 17.13. So that's check off part A. Okay, next, for part B, what angle will the first balloon make with a straight line to the airport? So we want to know, what is this going to be? Okay. So, in this case, now what we do is we can have, excuse me, we have a pairing. Okay, we know that the x here is 17.13, so we're going to use that with the 70 degrees to find out what this, we're going to call that y is. So we have sine of 70 over 17.13 equals the sine of y over 17. So 17 times the sine of 70 divided by 17.13. Know the inverse sine of that answer, and we get y is equal to 68.84 degrees. There we go, both things. Here, number 5, a slide. So we have a slide with a ladder. Oh, that's an ugly slide. I'm sorry about that. That's just bad. So we have a slide with a ladder. The slide is 3.9 meters. Makes a 35-degree angle with the ground. How many meters is the top of the slide above the ground? We want to know this. So this is a right triangle problem. So this is the opposite. This is the hypotenuse. That means we have to use the sine function. So the sine of 35 is equal to the opposite over the hypotenuse. Looks like that. So there's our setup. 3.9 times the sine of 35 gives me 2.24. All right. Angle of elevation from a point on the street to the top of a lamppost. So here's a point on the street. Here's our lamppost. Angle of elevation is 22 degrees. The lamppost is 8 feet tall. How far is the point to the street, on the street to the base of the lamppost? We're looking for that side. So if that's our angle, this is the opposite, this is the adjacent. We are using tangent to solve. So the tangent of 22 is equal to the opposite over the adjacent. So I have 8 divided by the tangent of 22 gives me x equals 19.8. Here we're just giving you triangles and trying to find the missing pieces. This is a right triangle. This is the adjacent side and the hypotenuse, which means we're going to use cosine of x is equal to the adjacent 16 over 25 hypotenuse. So to find an angle, you're going to do the inverse cosine of 16 divided by 25. X will equal 50.2. Here we have the opposite side and the adjacent side of this angle. So the cosine of beta is equal to the opposite over the adjacent. So the inverse cosine is 30 divided by 43, and beta equals 45.76. Oh my goodness, there's a lot left. Okay. Now we're finding a side. Based on the angle that we're given, this is the opposite side and the adjacent side. So this is the tangent of 70 is equal to the opposite over the adjacent. So 14 times the tangent of 70 equals 38 point, that's an ugly 8.46. And then here we have the opposite side on the hypotenuse. So this is going to use the sine function of 33 equals 5 over c. Okay, so 5 divided by the sine of 33. C is equal to 9.18. All right. For the problems here, we're going to be using law of sines or cosines, and again, it depends on what you're given as to which problem you use. So the first one, we have C and C, which means it's a pairing. We use the law of sines. So we have the sine of 100 over 1 is equal to the sine of A over 2. So we have 2 times sine of 100 divided by 1, which is the same thing. Do the inverse sine of the answer to find out that this is not a triangle. You have an error message that comes up in your calculator when you do this problem because it's not a triangle. Number 12, we're given a pairing. We have B and B. So we have sine of 100 over 5 equals sine of C over 3. There's the setup. So we have 3 times the sine of 100 divided by 5. Do the inverse sine of that answer. And C equals 36.22. Now, because we're doing laws of sines, we should check to make sure that there is not a second triangle. In order to do that, you take 180 minus the angle we just found, 36.22, and you get 143, okay? So let's just say, for the sake of argument, this is 143.78, which is what you'd get. The problem you have is, with our given angle of 100, 100 plus 143 is way over 180, so that cannot exist because it's too much. It's too many degrees in a triangle, okay? There's not enough room for a third angle in there if those two are taking 273, or 243 rather. So there's only one answer, and it is that one. Number 13, there is no pairing. We have A, B, and C, okay? Well, we want to find the measure of angle A, and since there's no pairing, it's going to be the law of cosines. Okay, so we have 5 squared is equal to 8 squared plus 9 squared minus 2 times 8 times 9 times the cosine of angle A. Okay, notice the A's are both on the outside. You have A here and you have A here. Okay, so we're going to solve this for cosine of A. Now the tricky part of this is you have to do it correctly. You can't combine the 8 squared and 9 squared with the negative 2 times 8 times 9, because the negative 2 times 8 times 9 is also being multiplied by the cosine of A. So we're going to do 5 squared minus 8 squared minus 9 squared. Get an answer. It's going to be negative 120. I'm going to actually write this one down to help you guys out. And then we have negative 2 times 8 times 9 gives you negative 144 times the cosine of A. We're going to divide negative 120 by negative 144 and then take the inverse cosine of that answer. And we're going to get A is equal to 33.56. Okay. Number 14, we're given a pair. We have both B's, which means the law of sines. So we're going to do the sine of 20 over 5 equals the sine of A over 12. So we have 12 times the sine of 20 divided by 5, inverse sine of that answer to find the angle, gives us 55.17. Now again, because we're using law of sines, we should check to make sure there's not a second triangle or a second angle. So we take 180 minus 55.17 gives us a possible triangle, possible second angle of 124.83. Now again, we have to check this with the angle that we're given, which is 20. So if 20 plus 124 is less than 180, so that means there is room for a third angle in that second triangle, which means these are both answers. All right. Lastly, number 15 and 16, that's it for this. To find the tangent of the angle. So the tangent is the opposite over the adjacent. So tangent of the angle is opposite over the adjacent. Now for this, you should reduce it. So we have the tangent of theta is equal to 3 over 4. It does not ask us to find out what theta is. It asks us to find out the tangent of theta. This is the tangent of theta, 3/4. All right, last one, 16. Wants to find the sine of angle alpha. Now in this case, to find the sine, we need to find the hypotenuse, which means we need to use the Pythagorean theorem. So we have, I'm going to say that's h. So if h squared is equal to 9 squared plus 4 squared. So 9 squared is 81 plus 4 squared is 16, which gives us 97. So we're going to have h is going to be actually equal to the square root of 97. Okay, so if we want to find the sine of that, we're doing the opposite. Opposite is 9 over the square root of 97. Now, in math, you're not allowed to keep square roots on the bottom of your fractions. You're going to multiply to the top. So you're going to get sine is equal to 9 root 97 over 97. This is your answer. Okay, in order to find the sine for 16, you have to find the hypotenuse first. So you can, once you've had the hypotenuse, you can find the sine. Without the hypotenuse, you're not answering the question correctly. All right, and that is our